determine the first 5 terms of the sequence if a sub 1, the first term, equals 3, and r, the common ratio, equals negative 4. Because we're given the common ratio r, we know the sequence is geometric. Well, to begin, we know a sub 1 is 3, so we can go ahead and record the 3 for the first term. And there's 2 ways we can determine the remaining terms. We can write the formula for a sub n, where for every geometric sequence, a sub n equals a sub 1 times r to the power of n minus 1, which means in our case, a sub n is equal to 3 times negative 4 raised to the power of n minus 1. And then from here, we can simply substitute n equals 2 to determine a sub 2, substitute 3 for n to determine a sub 3, substitute 4 for n to determine a sub 4, and substitute 5 for n to determine a sub 5. However, because we're looking for 5 terms in a row, it's probably faster to recognize that for any geometric sequence, a sub n is equal to a sub n minus 1 times r, which means to find any term in the geometric sequence, we take the previous term and multiply by the common ratio r. Using this formula, a sub 2 is equal to the previous term a sub 1 times r, which is equal to 3 times negative 4, which equals negative 12. A sub 3 equals the previous term of a sub 2 times r, and since a sub 2 is negative 12, we have negative 12 times negative 4, which is positive 48. A sub 4 equals the previous term of a sub 3 times r, which is 48 times negative 4, which equals negative 192. And a sub 5 is equal to a sub 4 times r, which is negative 192 times negative 4, which equals 768. But I also want to show how to set this up using the formula a sub n equals 3 times negative 4 to the power of n minus 1. We could also determine a sub 2 using the formula a sub 2 equals 3 times negative 4 to the power of n minus 1, which in our case would be 2 minus 1, which does give us 3 times negative 4, which of course is negative 12, giving us the same result. A sub 3 is equal to 3 times negative 4 raised to the power of 3 minus 1, which is 3 times the square of negative 4, which is 3 times 16, which equals 48, the same result. A sub 4 is equal to 3 times negative 4 raised to the power of 4 minus 1, which is 3 times the cube of negative 4, which is 3 times negative 64, which equals 192. And finally, a sub 5 is equal to 3 times negative 4 to the power of 5 minus 1, which equals 3 times the 4th power of negative 4, which equals 3 times 256, which equals 768. Whichever method we use, of course, we get the same first 5 terms. I hope you found this helpful.